Our next presentation is Consistency in Roasting by Rob Hoos. Rob in the house. Rob is a coffee roasting consultant and owner of Iteration Coffee in Rainier, Oregon. Rob is the author of Modulating the Flavor Profile of Coffee and has been a roaster since 2008. He has extensive experience in the specialty coffee industry, including roasting, training, purchasing, and profile evaluation. He's a subject matter expert for the Specialty Coffee Association and conducts coffee roasting workshops online and in person at his lab in Rainier, Oregon. Thank you to our session sponsor, Theta Ridge Coffee. Rob, welcome. Rob. There he is.
I'm here.
Sorry,
my slideshow actually locked me out of alt tabbing, which was really interesting. So I feel you, Trish, on some tech difficulties there.
I know. I'm so sorry. I hope that that's not something with Zoom, but
nah, we'll get it here.
We will.
Hi, everybody.
Everyone's so patient. Rob, thank you so much for being here. I'm turning this over to you.
Okay, I will share screen here. And let's go full screen. Just to confirm, everybody's got me full screen now, yeah?
Yes.
Awesome, cool. Well, what I wanted to do today was talk about consistency in roasting. And this is something that as a production roaster, I always secretly enjoyed. And for those of you out there who are production roasters, I don't know if you're like me, but I used to get incredibly excited when I would actually hit my targets and nail a roast. So much so that oftentimes I would go over to other friends I worked with and tell them how excited I was, which probably was very boring and lackluster for them. But for me, it really meant something. And what it means is that you controlled the roast well. Like you were able to take the machine, you were able to take any sort of agricultural differences that existed in that lot, any environmental differences or mechanical differences, and you were able to kind of tame them and have the coffee roaster do what you were expecting or hoping it would do. And as I work as a consultant, I run into people all the time that are struggling with consistency or struggling to understand how to be consistent. So kind of wanted to touch on that today. Another fun part of it was that for the iteration box sets I've been doing, I'm having to roast 4 batches that are identical to blend together to send out for the box sets. So I had a lot of like really recent data to use. And so I was really excited to be able to share that too. So that's kind of where we're diving in. So let's just start from the very beginning, and we're going to kind of move progressively through. We'll start with talking about our environment, talking about our green coffee, talking about setting up the roast, your charge temperatures and between batch protocols and stuff like that, how we handle ourselves during the roast, and then how we take post-roast data, and then look at just a couple case studies on being consistent in roasting. So the first one is controlling your environment, and I don't have a lot to say about this because, you know, while it's possible that some of us live in this environment where we're able to have air conditioning and humidity control and temperature control, for most people that are production roasting, you're not going to have the same environment day in and day out. Our warehouses are just not set up for that. And the roasters that we use produce heat, which causes the entire environment usually to heat up during the course of the day. So while there are a few places I've been where they have full control over their environment, that's not usually the case. So I do want to touch on 2 ways in which temperature and humidity in particular impact roasting, or I've seen them impact roasting. One of them is that temperature tends to impact a few things. Number one is going to be the starting bean temperature. So if you come in and roast on a day that is 20 degrees centigrade or 70 degrees Fahrenheit, that's going to be a lot different than coming in the middle of winter. If your space is not very well climate controlled, the beans are going to start out at a lower temperature. They're going to need more energy, probably not that much, but more energy to push them from that cold temperature to a hotter temperature as you're going through the roast. So you may need a little bit more energy, obviously, when the beans are cold. Also, the temperature of the air that you're pulling through your roasting machine, you have to heat that. Most coffee roasting machines are primarily convective in terms of how they heat the coffee. So it's not enough just to have a hot drum. You also have to heat the air. And so if the air is coming in significantly colder, then you're going to have to work harder at heating that air through the system to get you to the same point. Complicating this issue is humidity. Humidity impacts a few things. One is going to be that it does change your fuel and air mixture when you're roasting, whether you're using typical atmospheric burners or even a power burner. If you're not using electric coils, if you're using gas, it's going to affect the efficiency of the gas, because the more humidity you have in the air, the less by percentage oxygen you have in the air for combustion. So in extreme changes in humidity, I've even known people who have adjusted their burner to accommodate for that, so that they're basically doing minor tunes to their burner to make sure that their fuel oxygen mixture is optimum, so they're getting the most BTU out of their burner that they can. Oftentimes, I've experienced lower heat energy output from the roaster because I'm having impartial or incomplete combustion when it's incredibly humid out, and then when it's dry, I tend to have a little bit better combustion if I'm not changing it. So generally speaking, dry air, I get a little bit more heat energy out of my roaster, whereas wet air, I tend to get a little bit less heat energy out of my roaster. So that does change how I consider my burner settings, how I consider my charge temperatures, and all of those sorts of points. Do the best you can. It's not possible probably that you're going to be able to fully control it, but do the best you can. And when you notice changes or shifts on your weather station, whether you're using like a Cropster ambient sensor, or you've just got a little weather station from the store, pay attention to that, take notes about it, because it's also going to impact when you look back on your recipe, some of the roasting changes that you made. Like your charge temperature may have worked during your initial environmental conditions, but it may not work during your environmental conditions today. So just blindly looking at a recipe without noting what the weather was like, or what the temperature in the roasting area and the humidity was like, might be kind of putting you at a little bit of a disadvantage. Now let's dive into data collection. So data collection is a really important thing that we do, not just for like the amazing presentation that Trish just gave us about green coffee and taking a look at the green coffee, but it also helps us when we do our green coffee data collection, think about how we're going to roast the coffee. So I do want to touch on that. What should you be tracking? I'm not going to put out any standards that are unachievable. I think moisture content once per month would be ideal. Green coffee does age over time, and as it ages, the moisture content of the coffee will change. I've seen everything from, in good storage conditions, coffee is becoming slightly more dry or staying fairly stable, to in poor storage conditions, coffee is becoming wetter or remarkably dry. So checking on your moisture content once a month is probably a good way to just overall track where it's at. Density on arrival. I prefer personally to do water displacement density readings. I find those to be a little bit more helpful than the dry density readings, but as long as you have a baseline comparison, you can tell if a coffee is more dense or less dense than another coffee. That's really important. But so far as being able to compare to other people around the globe, you might notice your numbers are off based on the size of your graduated cylinder or the measurement device that you're using, whether it's a Sinar or something like that. Screen size variation on arrival, we'll touch on too. I've got a very low-tech way of doing that myself that I found to be helpful. And then notes from your sample roast and your cupping of the offer sample. I wrote offer coffee for some reason. So moisture content. Moisture content measurements are helpful for a number of reasons. One, it's going to help you understand a little bit about how the coffee is going to roast. It's going to help you keep an eye on the coffee aging over time. And it's going to cue you into how fast or how slow you might want to be working through the coffee. So how's the coffee going to roast? The way that I use moisture content to think about how the coffee is going to roast is that water typically wants to absorb a tremendous amount of energy. So when it's below 100 degrees centigrade, it's going to help conduct energy into the inner parts of the bean and all that sort of stuff that we've read in different heat transfer related works. But one of the things that I would point out is that once water starts to get above 100 degrees centigrade, it starts to want to go through phase change from liquid into gas. And the latent heat of vaporization talks about the amount of energy it takes for water that's liquid at 100 degrees centigrade to make the jump to gas at 100 degrees centigrade. And it's a tremendous amount of energy. It takes more energy for it to make that phase change jump than it took to heat it from 0 degrees C up to 100 degrees C as liquid. And so as we're roasting coffee, the wetter the coffee, the more energy water is going to be absorbing to try and make its phase change. And so the less energy we have available to really do the work of turning the beans brown. So when I have a wetter coffee, generally speaking, I'm going to anticipate having a more difficult time roasting it, a more difficult time pushing heat energy into it. And so if I'm trying to roast relatively quickly, I know that I'm going to have to increase my charge temperature, increase my burner, those sorts of things. In addition, as water does evaporate from the surface, it carries heat energy away from it, away from the coffee bean. And so sometimes you'll notice as you're roasting along, maybe a wetter coffee, depending on its, it's really complicated, right? Because it has to do with density, it has to do with moisture content, and perhaps the water activity. But what we see happening is some wet coffees crash really, really hard after first crack. They're releasing a lot of energy, and all that energy is drifting off with the steam that goes out the exhaust tube on the roaster, and we start to plummet in terms of our rate of rise. And some coffees don't do that. So, but usually wetter coffees, I will anticipate them doing that. And then once I've roasted it once, I'll kind of know what to expect the next go around. So that's how I use it regarding planning my roast. How to use it during coffee aging. During a coffee's life, it's going to have a tendency to dry out. It's not linear and depends on storage conditions, but it's an oversimplification. As the moisture content changes, it's usually safe to say that the coffee's quality may deteriorate or will deteriorate. So as coffee gains moisture, loses moisture, gains moisture, loses moisture, some of the things you originally fell in love with coffee are probably not going to be applicable anymore in terms of flavor profile. So tracking that is going to help you see how quality changes over time. And it's going to help you understand your weight loss readings. So weight loss in coffee roasting is primarily lost water content, whether it's the original moisture content of the coffee and the moisture that's generated during roasting coffee, because Maillard reactions and sugar caramelization both produce water as a byproduct. So the majority of what we're losing in terms of weight is going to be moisture content. If you have a coffee that you were roasting at 10% moisture content and you're ending up with a 12.5% weight loss, and suddenly you notice that the coffee has drifted down to 9% moisture content, you're going to have a very different weight loss at the end because you have less water to start. So as the moisture content declines, you would also expect the weight loss percentage to decline somewhat proportionally. So kind of bear that in mind too. And that's another good reason why it's important to take your moisture contents with some regularity so you can pay attention and track that. When to use the coffee. So Megan Pearson and Ian Freetham with Cafe Imports found that there was in their study a correlation between water activity and moisture content. Usually coffees with higher moisture content had higher water activity, and coffees with lower moisture content had lower water activity. So they found that generally coffee at the moisture content 11 or 11.5% may have significant quality losses over time than a coffee with lower moisture content would. So it is important to think about when you're receiving coffee and you get a coffee that's delicious, but it's at higher moisture content. Perhaps that's a coffee that you should try and use first, whether you run sales on it, whether you put it in a blend to try and move through it before it starts to deteriorate. I don't have my own personal research on this, but I do trust their findings and have found in a very loose way some of this to work for me. So there's the link. It's not clickable because this is a PowerPoint presentation, but if you go to their website, you can find it there. Density measurement. This is an example of a water displacement density measurement. The way that I use it is this. It's very simplistic, but hopefully you find it helpful. Higher density coffee usually doesn't suffer from the physical roasting defects quite as much as lower density coffee, and so you have a wide range available. You don't have to roast high density coffees fast, but you generally can roast them quicker without causing scorching or tipping as easily. Lower density coffees are a little bit more confining in that they sometimes will produce roasting defects a little bit more easily, and so perhaps you're better off roasting them a little bit more gently. So, high density coffee, whatever you want to do is fine. Lower density coffee, consider roasting it just a touch slower. And to kind of put brackets on what I mean by that, faster I'm usually defining as like first crack happening before 9 minutes, and normal medium to medium slow speeds would be first crack happening around 9 minutes. So if you've got a really nice low density coffee, you're probably not going to want to hit first crack at 7.5 minutes. Whereas if you have a high density coffee, that's totally an option for you. This is how to do water displacement density readings. So you take a graduated cylinder. I like to use my 50 milliliter graduated cylinder. You put it on top of a scale. You fill it to in this case, the 40 milliliter line. And then you add green coffee on top of the scale until you reach the 50 milliliter line. And then you know how many grams of coffee it took you to displace the water by 50 milliliters. What I really enjoy about this method is that because coffee sinks, we know that it's denser than water. Water's density is 1,000 grams per liter. And so it always weirds me out when I get a coffee density reading that is lower than 1,000 grams per liter. because that doesn't normally happen. The only time I've had it happen is with a kind of monsooned coffee, where it did happen, and it also had a lot of floaters. So there's that for you. But this is one way to take density measurements. I'd recommend playing around with it, see what you think, and if it doesn't suit you, then continue doing whatever you're doing. Screen size, how I use it, while using actual screen sizers is the ideal, I take a little bit more rough approach. I take a handful of green coffee before I'm ever going to roast it and look at it. If the screen size is relatively uniform, then I know that I'm going to be able to roast it quite easily, whether it's fast or slow, relatively uniform. If the screen sizes are consistent, as Trish was talking about bean shape when it comes to green defects, if the bean shape and size is consistent, then it's going to roast a lot more consistently. If it's not consistent and it's not uniform, then there's going to be variations if I roast the coffee too quickly. So if I have a coffee that I love, flavor is amazing, but the screen size is inconsistent, generally I will take a longer roasting approach or a slower roasting approach to try and help all the coffee rise up a little bit more evenly before getting it to first crack. So first crack, then push back 9.5, 10 minutes for what it's worth. Sample roast notes. How to use them. When you sample roast, you're able to collect the data, and you should be collecting data. You can get the final color of the coffee, whether it be whole bean or ground. You can get development time data, and you can get weight loss percentage data. And all of this data can help you on your early roasts hit your targets faster than if you just come in blind on your production roasts. Or come in without any idea of what you want to do with the coffee. If you love the sample, then you could reasonably recreate some of these data points on your production roast and get close to that sample's flavor on the outset. So take notes, use those notes, and actually do stuff with them instead of just sampling the coffee and then just saying, yes, it's good, or no, it's not good, and then no communication from purchase to the roaster, right? Charge and between batch protocol. It takes time. So there's no good way to rush a preheat on your roaster. And for those of you who have tried to rush preheat on your roaster, and I know you're out there because I've done it too, it doesn't really work that well. There is a minimum time for your roaster, and it is roaster dependent for your morning preheat. And generally I found that across roasting machines, you're really benefited if you give it about 45 to 60 minutes minimum. There's also a minimum amount of time you need between batches, which is going to be roaster dependent. You'll see that I recommend 5 minutes in a later slide, but there's just, you got to give it time in order to get all the metal up to temperature and all the air up to temperature and everything kind of set and stable so that you're able to be consistent between batches. So there's no substitution for time. The second thing for charging in between batch protocol is to monitor your air temperatures. I like to measure 3 air temperatures when I don't have beans in there. And you'll notice bean temperature is listed as an air temperature because there's no beans in the coffee roaster. It's just measuring the air temperature at that point. Exhaust air temperature, the temperature of the air exiting the roast chamber. This is frequently used when it's available to determine the charge temperature on the roast. So if you have a roaster with exhaust air, by and large, most people I've met that have those use the exhaust air temperature measurement to determine charge temperature. If you don't have any air temperature measurements, you're usually using bean temperature. But anyway, inlet air temperature is the temperature of the air entering the roast chamber. And this is a less common measurement, but as you'll see from some of the data I've collected, I'm going to really push you to try and consider it. And then bean temperature is the assumed temperature of the bean mass when roasting, but measuring the pocket of air outside the main airflow when preheating. A lot of roaster manufacturers try really hard to locate the bean probe somewhere where the air is not going to impact it as much. And so using your bean temperature probe for preheat or charge temperature may not be as handy as using the exhaust air temperature, because the idea is if everything in front of the air exiting the roaster is up to the right temperature and all of your settings are consistent, then the roaster should be at a consistent heat. Here's a roaster, and we're going to have this slide transition. There we go. Here's where they're located on a traditional drum layout. This assumes that this is a direct fired roaster that is taking kind of a more common path. Diedrichs actually have the opposite path. So the inlet is actually at the front where the exhaust is, and the exhaust is where the inlet is. But like San Fran's and Probats and my US Roaster Core all have this kind of setup. So the bean temperature is located on the faceplate. Inlet temperature, I like to position it at the top rear of the drum, assuming that the air inlet is in the back. The reason for the top is because air does striate in the roast chamber in which the drum is spinning, Even on my little 3-kilo roaster, I've measured the temperature at the top and the bottom of the roast chamber and had a over 100 degrees centigrade difference, so over 200 degrees Fahrenheit difference, top to bottom, which is pretty significant. So I'm in the hottest temperature air, which is also getting pulled through the top of the drum and measuring at the exhaust temperature. As the beans are getting thrown up into that airflow, it's absorbing heat energy and causing it to decline. So all 3 of these measurements are going to be crucial, and I'll show you why here. So you've got the data, it's useful, and you should use it. When I'm charging a roast, in order to be consistent, I'm looking at all 3. So my exhaust temperature is the one that I want to be on point. I want it to be as close as possible to my desired charge temperature. You can see here my sigma, or my difference between them, is about 1.1 degrees centigrade on these roasts that I was doing for production for iteration. So these are 4 roasts where I'm trying to just exact, right? My bean temperature was about 1.3 degrees centigrade difference, and my inlet temperature was about 19.8 degrees centigrade difference, which seems like a lot. But I do want to point out that there are different thresholds for each of these. So I'm okay with a little bit more movement and difference on my inlet air temperature, as long as it's within a range. If it was like 30 degrees centigrade difference, I would not charge. I would wait until my inlet temperature came back up into alignment with where it should be. And then I would actually take the coffee in. So I usually use one that's on point, which for me is exhaust air. That one has to be exact. My bean temperature should be in a range, and it's usually a relatively small range. My inlet temperature should be in a range, and it can be a little bit of a bigger range because of how that one's measuring. But if it's not within that particular range that I've set for myself, then I wait and let everything kind of come back up into equilibrium. Or if need be, I would kind of restart my process of charging or between batch. Now, what's really cool about this, and what's really cool about monitoring these temperatures, is that I found that you don't have to be as stringent about your time between batch protocol. Normally, I would recommend like, hey, 5 minutes, you're doing production roasting, you need to just go with it really quick. For my own sake, I have variable time in between these batches because I'm doing data collection, I'm thinking about how I'm going to do my next roast, yada, 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 on and on, right? But here's what it generally looks like. So you can see that my curves were pretty much right on top of each other. There is, as you can see, a little bit more variation in my inlet temperature, and that's just due to a little bit of thermocouple noise, as well as just the positioning of it. Could do a little bit better with positioning probably, or go with a slightly thinner probe to try and eliminate some of that noise. But, you know, and this is all in centigrade too. So my inlet max is hitting 416 degrees centigrade there right before I turn the airflow up to 100%. But using all 3 of these data points is going to help you drive your roast better, and it's going to help you charge more consistently because it's giving you the full picture of what's happening in your roaster instead of relying on time, consistent adjustments, and one data point. Other things to consider when you're doing charging between batch protocol: consistent settings. So your burner should always be set the same during warm-up. For me, it's 5 inches of gas on the water column because I've got a water column gauge, always 5 inches. That's how I charge. That's how I warm up in the morning. That's how I do my between batch protocol. So burner settings should be consistent. You know, and you should be charging from the same direction. Some people will go over their charge temperature and then on their way down they'll charge in. That's okay if you're doing it that way every single time. You're actually losing momentum inside the roaster, losing heat energy inside the roaster. The thermocouple reads it, you charge in, and that's fine. I do recommend usually going up to it, so like charging up to your charge temperature and then dropping the coffee in. But as long as you're doing it consistently, that's the most important thing. Consistent settings on airflow. You should have the same airflow setting through your warm-up and your between batch protocol. Airflow speeds are going to change the needed charge temperature for a particular batch size and roasting style, so being consistent is important. I learned this the hard way when I first started roasting on my little 3 kilo because I accidentally left my airflow set at 50% and I charged to the same temperature I would normally charge to if I had my airflow set at 100%. And lo and behold, I got scorching across the entire batch, and it was a really expensive coffee that I was roasting too. So that was really unfortunate. So pay attention, make sure your airflow is set the same way every single time. It is best if you can measure the volume or speed of the air so that you're not reliant on guesswork. As we'll talk about a little bit later, dampeners can give you a little bit of guesswork. Even dials can give you a little bit of guesswork. So actually having something to measure it, I think is really important if that's an option for you. So an example of a preheat protocol, this is from my US Roaster Core. 60 minutes, it's a 3 kilo, 60 minutes to charge temperature, 5 inches of water column gas, 0.3 inches water column on airflow, which is roughly 50% of my fan speed, drum speed at 100%. And I never change my drum speed. We'll talk about that here in a minute. My between batch protocol is ideally 5 minutes, but it can vary if I use my air temperatures correctly. 4 inches of gas and 100% airflow when I discharge into the cooling tray. When I'm ready to start preheating the roast again, I turn the airflow down to 0.3 inches and turn the gas up to 6 inches. So once again, whether this probably wouldn't work for your machine, but this works great for my machine. And the important thing is just finding what works and being consistent. So once again, exhaust temperature for me is on point, bean temperature is close, and inlet is also close or within a particular range that I've set for myself. Quick notes, much of the early part of the roast curve is going to be due to your charge temperature. So when you first start roasting, if you make a minor burner adjustment, you may not see that change happen for the first couple minutes. And the reason for that is because your preheat conditions, the temperature of the air that's moving through the system, the temperature of all the metal, that's really kind of dictating how everything happens at the very beginning of the roast. So it's worth paying attention to. Some roasters are different. Sometimes you'll see adjustments happen almost immediately, and sometimes you'll see them happen 5 minutes down the road. So just be aware of what your system is like. And when you make changes, sometimes you have to make drastic changes, especially if your charge temperature is the same. One example that I can give you is I tried to do a soak at 5 inches of water column, where normally I'd go up to 9 inches right out the gate. And it wasn't significantly different enough. And so my 5-inch soak did nothing. I went back and did it with a 3-inch water column soak, so another 2 inches less gas, and I had a significant difference. So, the 5 inches didn't work out, the 3 inches did. Pay attention. So how do we use profile data during the roast? Let me take a quick water break. Profile data during the roast. We've got all this data. How do we use it? Use all the data. Everything that you have access to, you should be paying attention to, which seems overwhelming, but it does get easier over time. So I want to tell you about what I use as kind of an early warning system for myself, and in order to see if my roast is drifting off course. So this is general airflow through the roaster. The little blue box is the heat source. The air is heated, it rises to the top. That's why we got dark red line along the top and orange and yellow along the bottom, because the air down there is a little bit cooler. The air up top is going to be the hottest. All that gets sucked through the back of the drum. So the first thing that's going to register a change is going to be my inlet temperature measurement, because it's the first thing that comes in contact with the energy or the air that I'm supplying to roast the coffee. As it moves through the roaster, the second thing that it should come in contact with is going to be the bean temperature measurement, right? Because that's just kind of where it falls in line. The third and final is going to be my exhaust temperature measurement. But this isn't actually how it works out in real life, because the beans take time to absorb heat energy and take time to change and disperse that energy out into the bean mass. And the scale is relatively large. So when you're roasting on a data logger, you usually will have anywhere between 300 or 400 C at the top and 100, 150 C at the bottom, maybe even lower, 70 C depending on your roaster. So your scale is tremendous. So it's really hard to see those small changes. So the way that we actually see changes happen when we make an adjustment is first the inlet changes. Secondly, the exhaust air changes because the inlet has changed. The coffee is absorbing energy still, and the inlet or the exhaust shows the result of that. The third that we actually see is the bean temperature rate of rise, and that's primarily because the scale is so much smaller. So it might only be 12 to 20 degrees, whereas your main scale looking at bean temperature is significantly larger. So even though bean temperature rate of rise is a derivative of the actual bean temperature, visually we don't notice the changes until after we've noticed the changes with the bean temperature rate of rise. So the way I use this is, if my inlet temperature starts to drift off course compared to the roast that I'm trying to match, I start paying attention to it. I don't necessarily make any changes yet, but I do start paying attention to it. If I notice then my exhaust temperature measurements start to drift off course, now I'm starting to think about what actions I'm going to take to correct the issue. So if my exhaust temperature is drifting off course, it's like, okay, do I need to make an adjustment? There's other things to consider, as we'll talk about. What kind of adjustment do I need to make? And should I start incrementally making it now? By the time my rate of rise starts to drift off course, I need to make the adjustment. And so I will usually then make an adjustment, sometimes a little bit more of a drastic adjustment to make things work. And then finally, I'll see it show up on the bean temperature if I haven't done my job of catching it ahead of time. So when you have these data points, not only does it help you charge more accurately, but it also helps you to roast more accurately and kind of take all that data into account. Here's an example of that. So you can see I was roasting along here, and this is one of the production roasts I was doing. The green line was my first batch. Or sorry, the green line was my second batch. The blue line was my first batch. So I was trying to mimic it with the green line. And you'll notice here that as I was getting up toward my burner adjustment, I didn't just blindly make my adjustment and say, oh, well, you know, my temperature measurement's close enough. I'm not that far offline. Let's go ahead and make the adjustment. I delayed the adjustment because not only was my bean temperature a little bit lower, but my exhaust temperature was also lower. And since both were lower, I knew that I was just kind of being a little bit sluggish in the roast and that I needed to wait to do that burner turn down until a little bit later. So I kept the burner up hotter for a little longer. Then I dropped my burner more significantly to kind of line back up with what I was doing with the rest. And as you can see, it finished out fairly standard, which was wonderful. All right. This is another roast, kind of the same sort of idea, except this one, everything looks great, but you'll notice I'm making some severe turndowns on the green early. And this just has to do with it being the fourth roast of the day. So my first roast of the day versus my fourth roast of the day, I had to make some adjustments because I knew that the roaster was holding a lot more heat. One of the things I also encourage you to do when you save a recipe is talk about which batch it was during the day. Because if I saved the green line, for example, and said, here's the recipe, this one's the gold standard, let's use it. But I didn't note that it was the last batch of the day. And let's say a week from now, I came back and tried to roast it. I would try and follow similar burner settings probably and be like, wow, I am drastically underpowered. What's going on? And what's going on is just that I never notated that the recipe I'm following is from a later roast in the day. So I had a lot more energy stored up. Different ways of controlling the roaster. Switch over here. Sweet, doing good. Burner control, how to run your burner for consistency. So during charge or between batch protocol, burner should be set the same way every time. Generally speaking, and rules are always meant to be broken when it comes to coffee and jazz music. And so I would like to suggest that there's always a caveat, but generally speaking, people roast from a high burner setting to a low burner setting. Sometimes they have a soak at the beginning, so they'll leave the burner off at a very low setting for maybe a minute, 30 seconds, minute and a half, whatever the case may be. But generally speaking, we go from high burner to low burner. I would recommend making smaller steps in your burner. So when you make your adjustments down, make them smaller, just to keep your roaster under better control, depending on its design. Some roasters, you could just turn the gas off and it would gently coast into some great, amazing roast. But that's not all roasters. When you make really drastic changes, it's harder to get the same thing to happen every single time. So smaller adjustments down, I think, can be really helpful. It does increase the number of adjustments you need to make, which can be problematic, but it can overall help you be more consistent. Often you'll repeat your same adjustments at the exact same time. This is the ideal for us as roasters when we act like a computer that's doing a burner recipe. It's like, oh, I'm at 5 minutes and then I'm at 160 degrees centigrade. It's time to drop my burner to whatever amount. That's awesome. But that's not going to be every time. And that's even probably not the way that most of us experience it. So as you roast, the roaster is building up heat, so you may expect it to turn down slightly sooner or use lower burner settings as the day unfolds. You might be charging at a slightly lower temperature as the day goes on. Also, I would encourage you to be careful with the idea about catching up with a roast. The only reason being you're creating a very tricky scenario for yourself. So let's say you do everything you think right, but you end up being a little bit sluggish in the early part of the roast. Can you catch up and hit first crack at the same time, have the right development time, have the right in color, and have the coffee taste okay? Absolutely, yes. Is that going to make it very difficult to control your adjustments? Also, yes, because what happens frequently is that there's so much heat energy in the system that you end up with a runaway roast. You go through development time too quickly, or you end at too high of an end temperature or too dark of an end color, and it just kind of messes everything up for your consistency. Fan speed airflow, generally speaking, while there are many different ways to run airflow, most people run it from lower airflow to higher airflow, or will run one setting the entire roast and not touch airflow at all. Usually low airflow is going to trap more heat in the system. It's going to allow the burner to heat the airflow to a greater extent, which is going to deliver hotter air to the coffee, which will cause it to roast faster. Usually speaking, lower air speeds are going to cause you to roast faster. Higher air speeds are going to cause you to roast slower. And I think that's part of why we do low airspeed at the beginning, higher airspeed at the end. It's not only to suck out chaff or smoke or what have you. I think it also has to do with having more control over the end of the roast and being able to slow down appropriately. Good, better, best. So a dampener is good, but air does compress and can move around the damper without slowing very much. So 50% dampener does not necessarily mean 50% airflow. However, if you're very careful, you can be consistent with a dampener. Variable frequency drive can be better. If the dial is reliable, then you can see the output from the motor and control it that way. So you're like, okay, I do 30 amps on the blower, and then I do 40 amps later on in the roast. A VFD with a gauge that measures pressure is probably the best for consistency and control, because not only are you changing the motor speed instead of worrying about air compressing, but you're also having a gauge to indicate whether or not that's different that day. I have noticed, and here, as you can see the little roaster behind me, differences during the day based on the pressure outside. So sometimes I have to adjust a little above 50% or a little below 50% to hit my 0.3 magnahelic reading. And that probably has a lot to do with the air pressure outside. Drum speed, set it and don't touch it. That's my recommendation for consistency in particular, but just in life in general. Once you find a drum setting that works for you, leave it. It's going to add a world of complications to your life to adjust your drum speed dynamically during the roast. If that's your style, then I'm all for that. You should totally do it. If you're asking for my opinion, I would recommend not messing with it. Data collection after roasting. Super important as well. When we talk about consistency in roasting, the way that we can objectively measure it is by taking post-roast data. Tasting is awesome, but people have proven over and over again to not be the most consistent tasters, especially when you're learning, right? So if you can do data collection after roasting, then you're going to be able to ensure that you're producing a similar product every time, even without tasting the coffee. Although tasting it is always good. You should do that too. The first one is easy and it costs you nothing but a little time. Your weight loss. I've met a ton of roasters who do not take dynamic weight loss. They don't take weight loss every single time. Weight loss is an amazing indicator of whether or not you hit your targets. You should take weight loss every single batch. It gives us an insight into how similarly the coffee is roasted. So using a color meter is great. Using a color meter in weight loss, I found that usually if I'm less than half a percentage point of weight loss difference from my baseline, everything is fine. And I'll usually track it and the color will track fine. I'll cup it and the coffee will come out fine. So assuming you've hit your roast profile and everything looks nice there and good there, and you've done a good job controlling it, if you're within half a percentage point of weight loss, then the coffee's probably super solid. If you're outside of that half a percentage point, if you've got greater than half a percentage point difference, then the coffee is going to taste different. And so it is worth looking at and tasting and doing triangulations with before you serve it or send it out. Roast color is important. Sorry, weight loss is basically free since you already have scales and buckets, but color meters are a little bit more expensive, but they are worth it. There's compelling research by Morton Munchau and Coffee Mind Academy concerning the importance of coffee's color. If you just look up beverages, Morton Munchau coffee, you'll probably find the research articles that they've written. But the bottom line is the majority of what we experience as flavor that comes from coffee is coming from roast color. It can be traced back to roast color changes. If the roast color is consistent, even if everything else is different, there's still a certain degree to which it tastes similar. So it is very important. It's not the most romantic endeavor within specialty coffee, but it is an important endeavor. I would recommend checking every single roast so that you have data to look back on to make sure that everything's consistent. Generally speaking, on the Agtron scale, plus or minus 3 points is consistent in color for me. If I'm on the roast vision scale, it's plus or minus 0 points. So depending on what scale you're on, it's going to be different. So on roast vision, I want to hit it dead on. On Agtron, I give it a little bit more room. Usually on color track, I'm like plus or minus 2. But you need to cup that out and kind of figure out what the differences are for you and for your production team. Tasting the coffee, because ultimately it all comes down to taste. As everyone's friend Ann Cooper says, we're in the business of flavor, and that's very true. So, you should taste as much as you possibly can the coffees you're producing. If there's not enough time, prioritize your tastings. Those that failed QC on data, so failed weight loss, failed color measurement, that sort of thing, or had a really weird looking roast profile, those should be checked, and then taste the others as you can. Make sure to have meaningful cuppings and tastings. Differences from control and triangulation cuppings are probably the most helpful for this consistency idea, because our brains, if we have two different sets of coffee, our brains say, well, these coffees are different. They were roasted at different times. They're different coffees, so they must taste different. And sometimes we'll find stuff that's not there. If you can't pick it out in a number of different triangulations, then you can't actually taste the difference between the two. So that's a good idea to do. I would recommend triangulations for your production cuppings as opposed to just tasting. But I do think just tasting everything once a week is really important, because you want to keep the team up on what all the coffee should taste like, or keep yourself kind of in the know on what all the coffee should taste like. A couple of case studies in consistency real quick here. 2 roasts separated by 97 days. Here they are. I was following all the things I just told you. I was looking at all 3 air temperature measurements, to make sure that I was charging correctly. I was using my Magna Helic on my airflow to make sure my airflow is set the same way. I was using my gas gauge, and I was monitoring the air temperatures as well as the bean temperature throughout the roast. And you can see I did do some changes here. You can see with the blue roast, I did keep my gas up longer. And part of the reason is you can see my air temperature is lower at my turn down on the red profile. And so I made the decision to keep the burner up for longer. Consistency metrics on this, you can see the duration. I was 9 seconds different overall. My development time was 4 seconds different. I hit first crack 5 seconds differently. My in temperature was half a degree Fahrenheit difference, which is pretty minimal. My roast value was 1 point of color difference on whole bean and 2.46 on ground. So I passed my metrics there in terms of plus or minus 3 on the Agtron scale. My color change was 1 second difference, and my weight loss was 0.35% difference. And well, the coffee's cupped the same, which was exactly what I was hoping for. 4 batches in a row on the same day. You can see here, I've got very different burner settings. The reason for the difference in burner settings is actually which roast came first, and then progressively, as the day went on, everything got a lot hotter. So I was able to lower my burner settings a little bit earlier. You can see here, I don't include air temps, but on the next slide, I do include air temperatures. So you can see my inlet temperature curves, my exhaust temperature curve, bean temp, and my rate of rise, kind of how those are all interplaying together. And you'll notice that even though I turned the blue down first in terms of going from 9 inches, which is my full tilt, down a bit, you'll notice that the inlet air temperature is actually right in the grouping of the other air temperatures. So it's really interesting that that one is really quite close and parallel with the yellow, even though they are controlled quite a bit differently. Here's my metrics on those, if you're interested. I know it'll show up in the video later in the recording, so. And then, questions and answers. But before I do that, I've got one last slide to show you because I think it's worth showing. This is what I meant by catching up. You can see the yellow roast was way behind. And what I did in order to catch up, which I don't necessarily recommend doing all the time, I lowered my airflow speed so that the air temperature got hotter, so that I was able to catch up more dramatically. So you can see that I'm basically, instead of being at 100% airspeed, I dropped down, and when I noticed that we were just not going to catch up, dropped my airflow down. That concentrated heat energy in the drum started accelerating the speed of the roast. You'll notice that I had to do a more dramatic turn down on my burner setting after I got my air kind of stabilized back up to 100%. It's a shame I didn't include the air temps on this, because the air temps were actually what I was using to drive. If you do have to take this approach, highly, highly recommend paying attention to your air temperatures, because if you hit first crack and your air temperatures are tremendously hotter than they are on your reference curve, you are not going to be able to slow down fast enough. So what I did was I made all my adjustments so that I got my air temperatures close to where my previous roasts were, so that when I hit first crack, my air temperatures were roughly the same. And that's what enabled me to control the roast and get the right development time to the right in color in this particular batch. So you can see the metrics here. Everything else came out great. In terms of whole bean color, we're really, really close. Ground color, we're once again really close. weight loss is identical amongst all of them, which is really cool. So yeah, what I'm going to do is go back to the questions and answer portion. So, and with that, I think I'm done. So I'm ready for questions. And hopefully I've not been talking to no one this whole time. Everyone heard me, right? Okay, good.
Yeah, no, you're good. I just was clicking in. Rob, you're the master. That's all there is to it. I'd like to introduce our guest commentator, Scott Merle. Scott is Senior Vice President at La Manita Coffee. Scott has spent a lifetime in coffee and has experience in every aspect of the value chain from barista to roast master. He has extensive knowledge of green coffee sourcing, purchasing, roasting, and is a proficient cupper. He's managed multiple international cupping panels and was a founding member of the Roasters Guild, serves on the editorial board for Roast Magazine, and has volunteered multiple SCA committees, including the Sustainability Council. Scott has dedicated his career to furthering coffee quality throughout the value chain and has emphasized and exemplified fair pricing practices to hardworking producers every step of the way. And that is a 100% true statement. Scott is a gem. Scott.
Good morning.
How's it going?
Hi. Great. This is awesome. Thanks, Rob.
Any first thoughts about the presentation?
Consistency, I mean, it's right there in the title. And whenever I teach anything about anything that has to do with coffee, consistency is always, it's always like the first thing that you really want people to think about, right? So it's the only way that you're going to be able to keep track of the things that once are changed, what impacts those are going to have on your end results. So consistency everywhere, in roasting, in storage, in inventory, in cupping, all of those things. So all, everything that Rob mentioned is applicable to other aspects of your business and your coffee life, right? The other thing is one of Rob's quotes from the presentation: "You've got the data, it's useful, you should use it," is like, there you go, right? The other thing that applies to too, and Rob mentioned it, is you have the equipment. If you've got a color meter, use the color meter. I mean, measure the color, right? Don't do it once a week, or don't do it. That's my recommendation, is if you've already paid for this equipment, then the equipment is not doing you any favors in your closet, on your counter, unless you're putting your coffee through it and measuring that and recording that, and then reflecting back on what that information can help you inform decisions, going forward and making your coffee better.
Awesome. All right, first question, and it's the age-old question. What is the difference between gas roasters and electric roasters? And what kind of parameters change when you're using a gas roaster?
So other than being able to say it's electric boogie, woogie, woogie, correct? So, no. It's mostly about the control. I do know that, gas roasters do tend to have more humid air moving through them, where electric roasters tend to have less humid air moving through them. Some of the work that Ann Cooper and I have done that has been published through Roast about consistency across roasting machines, I think applies as well to electric. I've not done that particular study with electric, but from me, from a non-scientific, just my gut take on it is that the heat source doesn't really matter to the coffee, but it does change how you drive the machine completely. Electric coil roasters are often a little bit less responsive to changes in the amount of heat energy you're putting into it. So if you're going from full electric coil down to half electric coil, there's a cool down process that it's going to take, depending on how much airflow you have moving across the coil. That can take quite a bit longer. So when you make an adjustment, you might see the change happen later down the line. Whereas, with the gas roaster, usually if you make the change, you'll see the change happen a little bit more immediately. So that would be my biggest take on it. In terms of flavor and stuff like that, my assumption would be that you can get the same flavor out of any roaster, whether it be gas or electric. The question is, how do you want to drive the machine? If you're willing to look ahead and electric is more convenient for you, and you want to avoid fossil fuels and stuff like that, then right on. If you want to have a roaster that's a little bit more responsive, like a sharper turning radius, like if you had like a really nice lawnmower or something, then you should get something gas that's going to be able to turn on a dime for you. but each roaster is going to be different. So
I can't even imagine how many times you've been asked that question.
less than you'd expect.
Really?
Yeah, it's a good
Scott, do you
question.
have anything to add?
No, I wouldn't. It depends on what's available to you. It depends on kind of what works for you, and you can use the data the same way. You can keep track of all the same sorts of things. I wonder, we've seen a lot of fluid bed questions too, Rob. Do you think that some of the same, or what would you say about that?
I'm still getting my head wrapped around some of the differences, to be honest. From a fundamental perspective, I want to be able to say that you can get the coffee to taste the same way, same roast style, no problem. And there is actually one scientific paper where they used a fluidized bed and did, like, I think they did GCMS or something like that, I guess. Yeah, and they compared them between a drum roaster and a fluid bed, and they were the same. But they roast way differently. So my experience roasting on the Akawa, which is the primary fluidized bed that I've used, over and over and over and over again, is that it's really hard for me to get the exact timings to work the same way as that would on a traditional drum, and to get the same whole bean and ground color distribution can be very challenging. So I would say that I think you can make amazing coffee on both. I don't think there's any limitations. I think that they probably have to profile a bit differently though.
All right. Instead of having a time frame for between batch protocol, would you recommend having set temperatures? Example, instead of 5 minutes between batches, bringing roaster to a certain degree below charge.
It depends on how much data you have. It would be my perspective. So if you have all three measurements, if you've got inlet, exhaust, and bean, then I would be comfortable with that, because I feel like you can figure out how much energy is actually in the system. If you only have bean temperature, or if you only have bean and exhaust, I don't think you have quite enough data to say, whatever, timing doesn't really matter. I think that at that point, you probably want to have a very consistent timing between batches too. That's just for my level of comfort. Can you pull it off? Like, I've seen people roast on roasters that have almost no data feedback and have very unideal conditions and make beautiful coffee. But for my comfort level, I would say I would keep the timing similar unless you have measurement of inlet and exhaust as well as bean.
All right, this question is, I understand your point about not charging drum speed dynamically within a roast, but what about changing the drum speed based on batch size? I found with smaller batch sizes, I need a smaller drum speed to keep the bean mass in the probe and to prevent roasting too fast.
Yeah, so that's the trick, right? Probe coverage is really, really important. And if you're using that as kind of a consistent metric. And so if your batch size is so low that you don't have appropriate probe coverage, then that could be very difficult. My perspective on it is that the drum speed changes the convection conduction ratio inside the roaster pretty tremendously. And so by lowering your drum speed, you're also not throwing the coffee up into the hot airflow. And so it's relying more on the conductive heat energy inside on the roasting drum. And I wouldn't worry about slowing it down too much, causing potential roasting defects and making it a little bit more difficult to control at the end of the roast. So yeah, I take the point, like, if you're being consistent and, like, my 50% batch size is always at this drum speed, then that's probably fine. That's not personally how I do it, but that would be fine. As long as you're not dynamically changing during roast and you've got like a set drum speed for a set size that you're always using, I would say.
Scott, you have anything to add?
No, I wouldn't add anything to drum speed. I think that is one of the things that can have some a greater impact than maybe you're hoping for if you're doing that. So consistency, it's the easy thing to kind of keep at one spot, but like Rob said, I mean, you have to take all these things comparatively too. So if you're talking with someone and they talk about what they do, and you understand that your roasting machine is different, your roasting environment's different, all your equipment's different, you have to apply some of your own experience to what those things mean to understand the impact that that's going to have on your own coffee, as opposed to what everybody else is doing.
What is the difference in your approach from washed to natural coffees?
Well, Scott, do you want to handle this one first? Y'all are all over the place with your ability to do processing.
I can get them processed. Roasting them is a whole nother matter, right? So this again, this is the sort of thing where your approach to roasting these coffees can vary, like, from A to Z. In how you want to handle these things and how you apply them. The trick is going to be, if you want to make like small incremental changes to a roast profile for like naturals from a certain place around the world, or to naturals that just arrived in the country this month versus naturals that you've had in your inventory for 9 months, you're going to have to rely on your data. You're going to have to keep close track of what all those things were, how the moisture content of your green coffee changes over time. As Rob said, you're keeping a record of all those different things. You know that your coffees roast a little bit differently at this moisture content versus this one. In the summer versus the winter when you're doing it, something like that. As long as you're keeping track of all this data and you understand that some of your heat application for natural coffees you're a little bit more careful with, or you're a little bit softer touch on some of those coffees than your just arrived, very dense washed Central American coffees. It's that experience is going to help inform your decisions as to how you manage those coffees over time. I mean, that's just a broad generalization, based on kind of what we're talking about and consistency and how to improve your coffee as you go along.
All right, and I think this goes along with that question too. When you get a new coffee in, how do you approach to find the perfect roast profile?
Assuming there is such a thing. So I would say, like, for example, kind of touching back on the last question and including this one in, like, when I get a natural processed coffee, I'm going to automatically assume shorter development time and lower end temperature than my washed. That's just kind of out the gate an assumption that I'll make. So if we're talking Ethiopia, for example, whereas a washed coffee I might develop 1 minute and 30 on a washed, I'll probably develop my first guess 1 minute and 15 on a natural. I might lose a couple degrees in temperature as well, and try and roast a little bit lighter, because they do have a tendency to gain some darker characteristics rather quickly if you're not careful. But my first way is always just looking at the sample roast that I got. And it depends on what I'm doing too. So if I'm buying a coffee for a blend, or if I'm buying a coffee for a dark roast, usually I'll use an existing profile that I have kind of as a baseline starter. Like, hey, the French roast is probably not going to be all that different from the French roast. So I'll roast it the same way, and then we'll make minor tweaks and changes to it. Whereas when I'm doing light to light medium, or even medium roast, I'll be looking at my sample roasting notes and say, like, wow, I really love this coffee with a 2 minute development time. I need to use a 2 minute development time on my first try, and see if I can get close to color, and see if I can get close to development time. So I kind of let the purpose of the coffee, and you shouldn't buy a coffee if you don't have a purpose for it. Like, you have to have something in mind for it. So I let the purpose of the coffee kind of dictate what I do for my first couple of roasts.
All right, great. Scott, do you have anything you want to add to that?
No, I mean, Rob talked about using sample roast data to help inform, production roasts. And as long as you're keeping track of a lot of the same things, and you recognize that the temperature, the exact temperatures maybe don't match from place to place, but the relevance of them will, you can pretty much match, what you wanted, what you got out of a sample roast that maybe made you fall in love with the coffee, or got you to buy it. You can generally replicate that in your production roaster. So that's a technique that you can use. I mean, if you've got the coffee to spare, then just running a couple of production roasts at a couple of different levels can give you the place to start too. If you don't, and if you've spent a lot of money on a coffee and you just know that you need to move into something where you're selling that, right away, then maybe doing your sample roast first is the place to start, and trying to match your curve that way.
Excellent. You just answered the very next question. All right. How does humidity in the roast changer affect the roast? Sorry.
So I know about the heat transfer differences we've kind of touched on. Generally, humid air is a poor conductor of heat energy. And so not only does it combust with a little bit less oomph, so you get a little bit lower BTU rating off your roaster on humid air, you're also not going to get as much heat conveyed to the coffee because the moisture in the air is grabbing some of that. At the temperatures we're talking about, right? I know people always draw the humid air analogy, like, well, why do I feel hotter when it's humid out? It's like, yeah, but thankfully we live in a world where it's not above 100 degrees centigrade yet. That's going to be one of the big things. You're just going to have less power overall. Now, in terms of the flavor of the coffee, we don't really know. My gut, once again, non-scientific, is that the humidity doesn't really impact the coffee because there's a tremendous amount of pressure pushing out. And so as you're heating the coffee, the pressure builds inside the cell structure and everything starts pushing out of the seed as opposed to infiltrating the seed. So when you're roasting, it's probably not an issue. Maybe it could impact cooling because then there is some impact, because once the coffee cools down, now you've got air rushing over it. So you could have a change there. But during the roast, it's probably not impacting the flavor of the coffee or the chemistry of what's happening inside the coffee, would be my guess.
All right. Any insight on how to use a PID gas controller efficiently for a large production roast? Any good resources? I'm seeing a lot of gas variation during the middle of the roast.
PIDs are tricky. And getting a well dialed in PID is not easy. So unfortunately, I don't really have any great things to be able to tell you like, oh, it's really simple, just do this. I would say make sure that the PID is less aggressive. So tune it to be a little bit less aggressive, because I think a lot of times the PIDs come in and they're just all over the place because they're responding really aggressively to temperature changes. But the most important thing, honestly, is setting it up so that you hit your turning point well. If you don't hit turning point well, depending on when the PID is taking over control of the roast, if you don't hit your turning point well, it's going to set up an oscillation where the roaster is actually going way out of control. So when you set up your baseline profile, make sure that your turning point is something achievable. Since they said it's a large production roaster, I'm assuming you're doing large batch sizes in it. So what I would usually do is actually set my turning point to an unachievably high temperature, because I want to trick the burner into jumping to 100% from the very beginning and just rocking it. And then I'll have it kind of gradually coast into realistic kind of before yellowing, so that whole first part, the burner's just pegged out, because the worst thing that can happen is you lose too much power and then you can't catch up. So that's kind of what I'd recommend. Maybe set turning points unachievably high if you're doing a full batch, so it keeps the burner pegged out, and then kind of have it coast in, and maybe adjust your PID so it's a little bit less aggressive. And note that burner controls don't necessarily mean that it's happening to your coffee, because once again, hot air is what's roasting the coffee in the majority of coffee roasters that are in existence. And if your air temperatures are stable, even if your burner is going up and down, the experience of the coffee is actually rather stable. So there's a certain point, I think, too, when you're using PID and automation, where you just have to let go of having a social media roast curve to post about how beautiful the coffee is roasted, and just accept that you might be getting noise that's not related to the actual coffee beans experience.
All right. There's a lot of questions in the chat about the bullet roaster. Someone commented they saw it in the back. So I'm just going to take a couple of those questions and maybe merge them together. What are your preheating suggestions for the bullet? And can Rob talk a little bit about approaching IR bean temp and its effect on the roast planning?
Yeah, so charge temperature, that's always a hard question to answer because it's so variable. So I can't really speak to that except to say that if I'm doing a faster style of roasting and I'm doing a larger batch, I might be charging up at 275 C, so 250 to 275 C. If I'm doing a small batch and going slow, I might be charging at 200 C or even lower. So it's all over the place. So for that one, it's kind of like very specific. So like let's talk at another time. I'll probably talk about my email at the end. In terms of the IR bean probe, for those of you who don't know, the bullet uses an infrared sensor to monitor the bean temperature surface while it's roasting. And it gives some really interesting results, and it's really encouraging. There is a great deal of consistency with it. I would say that for me, I still, because it's newer technology, I still take it with a slight grain of salt. So I wouldn't say that it's the end all and be all of beam temperature readings. So I usually use it in concert with the NTS 3mm probe that's inside of the roast chamber as well. And I have noticed variations with roasting styles in terms of when first cracks happening, in temps. There's variations in terms of batch size that come along with it, but overall it's pretty consistent, which is nice. So I guess that's a long-winded answer that maybe didn't even say anything, but so it goes.
No, it's good. I've seen this question a couple times too, worded differently, but people are wondering if you could give some tips on taking your sample roast production and turning it into your big production machine roast.
Yeah. So a lot of this comes from my my friendship with and my learning from my compatriot Morton Munchow and some of the research that they've done. And what I've found that works well for me is kind of following the same sort of idea. So like, let's work backwards. So end color is the most important thing. So we'll start there. If your sample roast and your production roast don't have relatively the same end color, they're not going to taste the same. So you should know on your production roaster relative what color equals what temperature, right? So if you do a sample roast and you do the testing on it, you say, wow, this sample came out at 65 whole bean, 107 ground agtron. You should know how to translate that to your roaster. This is where a color meter is actually quintessential and incredibly important. So if you want to match from sample roaster to the production roaster, you're going to have to buy a color meter, full stop. Because weight loss is even going to be different because you've got usually difference in terms of rate of roasting. So the weight loss isn't going to be as helpful. So get a color meter. If you can, ideally one that does whole bean and ground, if not at least ground. Get as close as you can color-wise. The next thing is going to be getting as close as you can development temperature or development time-wise. So how long was it in development? That's going to really impact some of the acidity and bitterness and sweetness and all that sort of balance. If you can nail the end color, whole bean and ground, and you can nail your development time, you are like 90% of the way there. Then I would take when first crack happens with a grain of salt. On my Akawa, I'm not going to be able to production roast that fast to first crack, just not happening. But if it's a faster roast on the Akawa, then I know I'm going to strive for a faster production roast. And if it's a medium to slow roast on the Akawa, and I love the flavor, I'm going to strive for a medium to slow production roast. So generally speaking, if it's like really crisp floral notes and stuff you're after, you're probably going to need to hit first crack 8 minutes or maybe even a little bit before. If you're looking for kind of more savory, sweet notes, then usually I'd push that back, but that's all stories for another day. Start with color, then do development time, and then try and hit first crack at a relatively consistent window, would be my take on it.
Thank you, Rob and Scott. It's such an honor to have both of you in our program. Thank you for sharing your knowledge with our attendees. It's truly priceless.